Hello, welcome to the Agile Business Suite 9.0 information series. My name is Karthikeyan Rajgopalan. I'm a principal engineer with Unisys and product owner for Agile Business Suite Client Tools. In this video, I'll talk about the new feature, the support of REST API in Agile Business Suite Windows. The agenda will cover these topics: support of JSON format data in external class, support of JSON format data in Messenger cycle, import wizard for web service, modeling REST API, and invoking REST API. In the previous releases of AB Suite, it was possible to send XML format data to external library via external class. With AB Suite 9.0, it is now possible to send JSON format data to external library via external class. In the previous releases, we had serialization under add new item, which was an interface that a class can implement, and the class can then be serialized into XML format string. In 9.0, serialization is split into serialization XML and serialization JSON. A class can implement either or both interfaces. The serialization to XML or JSON format string will be dependent on which interface is used for the transaction. Let us see a demonstration of this feature. Now let us consider this example. So we have a model with an external class, test lib class and external class. Which points to a .NET library, test library.dll, and which implements an interface iData manager and a method called process data, which accepts an input of type varstring. Let us look at this external library, which is a simple C# project, which has that method test data. So what it does is it receives the input and writes to a flat file in ctest.json, file name in employee.json. In this location right now it's empty. So that's all it does. So now we have a iSpec with a logic written something like this, and emp object populated with the values sent from user, which in turn sends to an external class. Now emp object is basically an instance of employee object which implements IEMP interface, which is basically serializable JSON. So that means when the data is sent across, it has to be serialized in JSON format. And yeah, essentially IEMP implements exposes these three members. So now we'll see how this shows up in action. Yep, that file has come up now. So whatever is sent, it's serialized in JSON format. So what has happened behind the scene is when it is sent to the external class, we specify the object along with the interface, the one which employee object implements. And apparently this one is of type serializable JSON. And the runtime understands that when it has to serialize, it has to choose the JSON serializer. Yep, but basically this feature is all about which we have implemented in 9.0 with respect to supporting JSON format data in external class. In the previous releases, it was possible to send XML format data in Messenger cycle. In AB Suite 9.0, it is now possible to send JSON format data in Messenger cycle. Let us see a demonstration of this feature. Let us consider this example. We have a model with a messenger class. EMP is a messenger class, stereotype messenger, and EMP implements an interface called IAMP JSON, which is basically of type ICLizable JSON. Now, IAMP JSON exposes these three members. What we have done here is we have overridden the respond method with a logic something like this. So basically, irrespective of input what you get, you send a customized response. Now let us see this in action. So we are invoking our custom messenger client, and need to send a XML format input. Yep, this is our input, and we'll transmit. And then you see a response matching with our logic here. So what has happened behind the scene is the messenger cycle has understood that you are sending a class which is bound to an interface which is of type ICLizable JSON. Then the runtime invokes the respective JSON serializer. Instead of an interface which is bound to ICLizable JSON, had you are sent ICLizable XML, then runtime would have serialized, invoked the XML serializer. So that's the gist of it. So this demonstrates this feature of support of JSON format data in Messenger Cycle. In ABSUIT 9.0, we have introduced an import wizard for web service. Let us see a demonstration of this feature. Now let us look at an example. So we have a empty model. We try to add new element. Then we see a wizard. And then we see web service, which supports different type like SOAP, WCF, and REST. For now, our focus is on REST. Now we'll point it to an OpenAPI file. We have it already downloaded in the system. On Discover, it tries to parse the OpenAPI file and list out the various endpoints and the REST verbs. So I put and post expose on pet and put as a request body with these members. Right. Now we let us look at the file which we have opened in the wizard. So the path, what we saw, the pet, the put verb, the request body, which is basically a component of type pet. Now let us look at the pet object. It has all these members: ID, name, category, photo URLs, tags, and status. And then that's what we see it here. So likewise, it lists out all the endpoints and the HTTP verbs. And then on clicking next, it will go and create model structures, which we'll see in the subsequent slides. So this demonstrates the import wizard feature which you have introduced in ABSUIT 9.0. Let us look at the model structures that gets created once we import an OpenAPI definition file. This is how the model structure would look like once we import the OpenAPI definition file. So in the OpenAPI definition file, we have different constructs like the path, the endpoints, and the verbs that is supported, like put and post on pet. Likewise, we have set of components that it's mentioned here. So all these structures will be get created in the model. So now let us look at the methods. So we do have a root class that gets created under which we have all these components and methods and parameters. So under that, we have all these methods that gets created. The convention is it starts with the verb and then the endpoint. Say put pet, and then you have post pet, In both cases, both conform to these endpoints. Under pet, we have put in post. So the same convention we use right across for all the endpoints coupled with the verb. And then you see a list of component gets created here. And if you look at the model, under pet store class, we would have a folder called components, under which you have all the component types corresponding to the one in the OpenAPI file. And there is also subsequent folder followed by iComponents. Those are the interfaces which these components implement. For example, iAPI response implements iAPI response, and iAPI response pin interface, which is basically a type iSerializable JSON. It's the same structure all across the OpenAPI file. It lists under one common place. Some of these endpoints have a request body, right? Some cases the request body would be a component type. In some cases, it is not a component type, but a schema structure defined, very specific to that endpoint. Say post pet by pet ID. If you look at this, say get on that post pet on pet ID, you have a parameter, and it doesn't have a particular schema that is in terms of representing it as a component, but it has a set of attributes that comprises a request body. But if you look at get pet, it has this very specific attribute that specifies. Or you take the case of post pet, you have a request body that confirms, that points to one of the component. So wherever the cases we have a component, we have a folder structure called component created and list all the components. And wherever we have the request body which doesn't conform to a component but it's on its own, we have a folder called request body and I request body. They go in pair. The class structure and the interfaces which it implements. So that constitutes the request body part of it. Likewise, for the response body, we have pet list and ipet list. In this case, get pet find by status. The response 200, anything written code with 200 is a successful response. And if it's successful, it basically returns an array of pet. So that's what this represents. Pet list has an item called list underscore pet, which is basically a list attribute of pet. Likewise, the corresponding ipet list will have list underscore pet, list attribute of type ipet. So that explains the response body part of it. Next comes the parameter. Yep. So most of these methods we need to pass a type of parameter, and parameter can be of type query or path or form or cookie, right? So we'll take this example of a path parameter. So it has a set of built-in methods, and one of this method is overridden, can be overridden, called put. This is the same structure across all the parameters, and when I say this is a parameter, thing to be noted is this is basically a class which inherits framework.rest parameter. This is newly introduced for the REST API. And the class structure is method that gets generated is homogeneous across all the type of parameters. So let's take this example. You see that most of the mandatory items, it needs a name which tells the type of the parameter or name of the parameter. And int is what is the type of the parameter, whether it is path or query, right? This is a case of path we're looking at. And finally, you would need to set a value which is basically assigned to the base class of this. And this is defined as var string. This is basically because you would pass a serializable class as a parameter, and that is defined as var string here. So this is a case of path parameter. We'll take this another example. So get user login. This is a case where it is a query parameter. So it takes a name and tells the type. So the structure is homogeneous because they all are a subtype of framework.rest parameter. So runtime would receive same object structure and then it would know that what's the type based on the in. That explains the parameter structure that is implemented. We also have other structure, the parameter list. We look at this. I can have a request where it can be a set of combination of these parameters. I can have a query parameter and a form parameter, a path parameter, all together comprises one request, one in particular endpoint, right? So what we do is, such cases, we pass a parameter list, and that would be an parameter which will be templated to framework.rest parameter list. So runtime behind the scene will know that all these are basically of type parameter rest parameter framework.rest parameter, and then subsequently internally it knows that each is a specific type because we would have set the type. The set in method specifies what is the type of parameter, and this structure is harmonious. It's all across the methods, the same structure we follow wherever you have to pass. Wherever we have to pass more than one parameter, it will be a parameter list of type framework.rest parameter list. And other thing of interest is most methods we create, which is created, has one variable called request, and that is of type framework.rest API. We just jump into one particular method, and this is the same structure across all the methods which you have created. So what this request does is it needs to know the enough information to compose a request, REST request. It needs to know the URL, it needs to know the endpoint, it needs to have the parameter, and then it calls this verb. So this case is a delete bit, so request.delete. Likewise, if you say a post bit, see the same structure we have. It needs to know the URL, the endpoint, the body, request body, and then it calls a post. Likewise for put. So this abstracts all the uh, required information so that internally it can construct a request message. And the structure, what you see, is the same across all the methods. So this explains the way the request is, okay, the structure is created to represent the REST API. So this is basically the overall the same pattern of model structure that gets created for any of these OpenAPI definition file. So this demonstrates the modeling structure of representing the REST API. Let us look at the logic that developer needs to write to invoke REST API with the necessary model structures created based on the OpenAPI definition file. Now that the necessary model structures are created post importing the OpenAPI file, now let us look at what are the changes the developer needs to do to invoke a specific endpoint. So in this case, I have created an iSpec, and then I have got a bunch of logic that basically exercise different endpoints. Let us consider a particular case of invoking postbed. So postbed endpoint would take a request body, which is of type pet. And if it is successful, you have a return code of 200. And anything on 400 series and 500 series indicate client side and server side error. So this is the endpoint I want to exercise. What I would do is I need to construct a parameter object. and that would be a type request body. In this case, request body happens to be a component of type pet. So in my iSpec, I would create a pet attribute, which basically templates to pet. Now, pet component has category and tag, which by itself are a separate component, like tag and category, what you see. So what I need to do is my spec, I would create category attribute and template it to category, pet store category, likewise tag attribute and template it to pet store tag. I'll finally assign create this category and tag and finally assign on to my pet object. And then on pet store, which exposes is endpoint post pet. As I said, right, the convention starts with the verb and then the endpoint. I would pass the request body and one successful message, right? It will be written code of 200. So either way, if it's not successful, then user needs to write logic and take appropriate action. So glb.rest written code would indicate the result of that particular operation, and glb.rest return message would indicate would give back the response message of that particular operation. If the whole operation itself had failed, no, whole REST API transaction, not not that the particular REST request is processed successfully, then glb.status would be set to 5 stars. So considering the REST transaction has gone successfully and maybe internally there is a server error or a client error, then glb.status is kept as it is. It is set empty string, but then the user developer has to write logic to take action based on the value you get from glb.rest written code. So this is the same pattern of invoking any other endpoints. I think yeah, this demonstrates the set of uh, things that developer needs to keep in mind while invoking any of the REST endpoint with already the model structures being created based on the OpenAPI definition file. Thank you for your time. I hope the information was useful.